Hi, all. It is Miss Mac here, wanting to talk to you today about discrete or continuous functions. So, the difference between them is very, very simple. If you have a discrete function, in order to trace it, you have to pick up your pencil. So, if you look at these top two graphs, if I were to trace this with a pencil or a pen or a marker, they are not connected points on this first graph here on the left. So I have to put a dot there, pick up my pencil, put a dot there, put a dot there. I'm picking up my pencil. That makes it discrete. The second one has some sections where things are connected, but in order to go from section to section, you have to pick up your pencil. So when I go from here to here and then I pick up to go over here, I know that this is discrete. So anytime you pick up your pencil, it's discrete. If I can trace beginning to end from left to right, without picking up my pencil, then I know it's continuous. That's the difference between the two. So, how do we need to use that? Well, we need to talk about domain and range and how those change, or how they change the way we write them, whether the graph is discrete or continuous. Now, I'm going to start with this continuous graph on the right. I know that when we graphed these earlier and we were talking about domain, we know we're talking about how far left and right our x's go. And you'll notice I already put the points on here. So I know that my farthest point to the left is this one right here, and my x at that point is -5. My farthest to the right point is this one up here, and my x there is 3. So I know my graph goes from -5 over here to 3 if I think about my x-axis. And I know, because these lines are connected, that everywhere along this line in between there's an x on that blue line. So in order to write the domain for this, what I have to do is I write my low number with x in between my high number. And so my low number, my farthest to the left, was this -5. And my farthest to the right was this 3. And remember, we're looking at the x's. And because those are both filled in dots, we have the equal to under the less than. When I am talking range, I know my range is how low to how high on my y-axis. So if I look for my lowest point, it's this one. And in particular, I'm looking for the y value. And my highest point is this one, and I'm looking at its y value. So my y's go as low as -4 and as high as 5. So again, I do the same kind of thing, only with y in the middle. And I always go smallest to largest. So my lowest y here was -4, and my highest y here was at 5. And both of those are filled in points, so those are going to have equal to's on them. So that's how we did continuous. Now, if you notice, this graph on the left, which is discrete, has those same 5 points. They're just not connected. So I know that I have an actual x of -5. I know I have an actual x of -4. I have an actual x of -2, and so forth. But I don't have all those ones in between like I did on the other graph where it's connected. So in order to show only specific values, I have no choice but to list them out. So what I'm going to do is just list these out, lowest to highest. And what I'm going to do, it doesn't have to be lowest to highest, but I'm going to do that because I'm going to go left to right. So I'd have -5, -4, -2, 0, and 3. And remember, I'm looking for all my x's in those ordered pairs. Now, my range is, again, only specific points. So I can't do one of these intervals like over at the right. I have to list them out. So now remember, I'm looking for these y's. And again, I'm going to list them out. And if I happen to get one that appears twice, I'm just going to write it once. So it would be -4, -3, 1, 3, and 5. So When you have a discrete graph, you're going to list out, just like right here, you're going to list out the specific numbers that are involved. When you have a continuous graph, you have to have intervals because, again, you have all those little points in between. We can't list them all, so we have to write inequalities. All right, couple more things. So what did we do with domain and range with arrows? Well, first of all, if we remember, as we look at a graph, the x-axis goes from left to right, and to the left is negative, to the right is positive. The y-axis goes up and down. Up is positive, down is negative. So if I have, let's say, for instance, an arrow that goes this direction, I know that arrow is going two directions. It's going right and it's going up. If I draw an arrow that's going like this, that arrow is going left and it's going down. And we could do that in each of the different directions we're going. This arrow would be going, I'm sorry, I made a mistake there. This, so sorry about that, is left and up. And then this one down here at the bottom is left and down. And if I have this, it's right and down. So when I look at this graph on the right and it has an arrow and I'm doing domain and range, to do the domain, I'm going how far left to how far right. But on the left, I have this arrow. This arrow is going two directions. It's going left, but it's also going up. So I got to keep that in mind. So if my domain is going to the left forever, we call that negative infinity. When we write these things, remember, infinities never have an equal to on them. I have x because it's my domain, and my graph goes as far right as this point. That's my farthest right, so my x for that is a 3. If I am writing the range, I know I'm going how low. This is my lowest point from -2. It's a filled in dot. And I know it's going up forever. And because it's going up forever, I know that's going to a positive infinity. So that's a quick review of how you find domain and range of different kinds of graphs. If you have any questions, see one of us. Talk to you later. Bye-bye.